Okay, so today we're talking about convergence factor on polar stereographic charts. Now, the convergency on a polar stereographic chart is defined at that point where the chart makes contact with the reduced Earth. So this is the Earth, there's the equator, this is the North Pole, and down here we have the South Pole. So the chart makes contact, for example, in the Northern Hemisphere with the North Pole itself. This point here is known as the latitude of origin. The latitude of origin varies on different chart types. So in this case, it's the North Pole or North 90. At that point, the meridians on the Earth converge at the same rate as the meridians on the chart. Here you can see there's no contact between the Earth and the chart. The contact is made at the latitude of origin. So it is this point that defines the convergence factor. Where do we find the convergence factor? Let me clean a bit this board off. So the convergence factor is found in a formula called convergency is equal to change of longitude, delta lambda, change of longitude, multiplied by the convergence factor. Now the convergence factor is also known by its mathematical term n. Now, what do you want to call it? A convergence factor, or n is immaterial. It's equal to the sine of the origin, which, as we've already shown, in this case, is north 90, or 90 degrees. So therefore, it's equal to the sine of 90 degrees. And the sine of 90 degrees is equal to 1. So the convergence factor on a polar stereographic chart, or rather the type of polar stereographic chart that's shown in the syllabus, is equal to 1. So therefore, the convergency formula is going to state convergency is equal to change of longitude multiplied by convergence factor, which is equal to 1. So if I take that out and move that up there, so now we say convergency is equal to change of longitude times 1. Any number multiplied by 1 is equal to itself. So therefore, we can delete multiply by 1 out of it altogether, and convergency on a polar stereographic chart is simply change of longitude.